In this example, we're going to be maximizing, which is one of the two linear programming examples. So when we maximize, we are normally going to see it in a word problem format. So first, we're going to read our word problem, which is this one. You have been tasked with purchasing filing cabinets for your supervisor's new office, who only wants 2 different types of cabinets. The office can only hold up to 84 square feet of cabinet floor space. The cabinets from Middles take up 6 square feet, while the cabinets from House Depot require 8 feet each. Cabinets sold at Middles cost $10 each, while the ones at House Depot cost $20. And you are given $60 to make your purchases. According to their websites, the ones from House Depot gives you 9 cubic feet of storage space, while the ones from Middles provide 16 cubic feet of storage space. How many from each source should you buy to maximize storage space, and how much storage will your purchase hold? So what I went ahead and did was cross off any information that is unnecessary so we can focus on the stuff that we want to use in our example. And I highlighted based on what our x will be. So x is Middles. I set Middles to x. It can be x or y. And then I highlighted what y will be, so House Depot. And then the yellow is any other information that will help us make our constraints and our goal, which is to maximize storage space. We always want to write our goal equation at the top. So what we want to do is maximize storage space. So if Middles provides 6 cubic feet of storage, we have 16x because x is Middles, and then 9y because Home Depot is y, and it gives us 9 cubic feet of storage space. So what we're going to do now is look at what we highlighted yellow, which will be our constraints. Floor space. The cabinets take up 2 different floor spaces, so Middles take up 6 square feet, so 6x, plus House Depot taking up 8 feet each gives us plus 8y, and the office can only hold 8 square feet of cabinet floor space. So our floor space, we can't take up more than 84 feet, cubic feet, or square feet, but we can be equal to 84 square feet. Our next constraint is the price of the cabinets. Middles cost $10, so 10x, and House Depot costs $20, so 20y, and we cannot spend more than $160, but of course we can spend up to or equal to $160. And then our last 2 constraints is we can't have negative cabinets, so x has to be greater than or equal to 0, and y has to be greater than or equal to 0. So now what we do with all this information that we have gathered is we need to put it into our graphing calculator. We don't put in the space goal, though. We only put in our constraints. Putting that in, I put the graph on the slides presentation, and I drew also our formal region. So we always want to draw the formal region and label each of our corner points. So we have 0, 8, 10, 3, 14, 0, and 0, 0. What we do with our points is what we want to do is we want to test them with our space equation, plugging in the x as an x and the y as a y. But we don't need to test all of them. We only need to test these three, because you can't have 0, we don't want 0 cabinets, so we want to at least have 1 and 1 cabinets, so we don't test 0, 0. First I tested 0, 8, so we have 16 times 0 plus 9 times 8, and we end up with 72 feet cubed. 14, 0 is 16 times 14 plus 9 times 0, which gives us 224 cubic feet. And then 10, 3, which is 16 times 10 plus 9 times 3, which gives us 160 plus 27, and we end up with 187 cubic feet. Looking at all of these, the one that gives us the most space, which is the cubic feet, is 14,0. So buying 14 middles cabinets gives us 224 feet. So this is our optimal solution, but before we're done, we always want to write a one-sentence explanation of our solution. So I wrote, buying 14 middles cabinets will give 224 cubic feet. And that is our solution.